All right, welcome everybody. Today we're going to do an introduction to ANSYS FEA with a notch bar, and we'll calculate the stress concentration. So I'll show you briefly where to go to download ANSYS Student, and then we'll create the notch bar, and I'll show you how to mesh it and set up the boundary conditions. We'll run the analysis and then interpret the results. So we'll calculate the stress concentration from the FEA model and compare it to hand calculations. And I'll also show you how to set up a linearized stress result that you can do with the model so that you can extract stress concentrations directly from the model, which is a typical method used in industry. For our case, we'll be modeling a notch bar with thickness H, width, which is defined here as large H. There'll be a membrane cross section with width D, and a circular notch with a radius R and an applied load P. So it's important to note here that if you find a stress concentration curve like this from literature, this one is taken from Peterson's stress concentration factors, and the book has quite a bit of stress concentration factors. But for our case, it's important to note that there's two curves. The first curve is going to be the stress concentration factor relative to the stress away from the notch. So as it's defined here, it would be the load P divided by the thickness times the width, which will be your average tensile stress away from the notch, like say in this section here. And that will give you one curve. And I've calculated that for our geometry, an H of 5 inches, a thickness of 2 inches, a notched circular radius of 0.75 inches. D would be 3.5, and the cross-sectional area away from the notch would be 10 inches squared. So for a 1,000 pound load, you'd have 100 psi tensile stress away from the notch in the membrane. You call the cross-section is typically referred to as the membrane, as far as I know. Now, to calculate this, you would plug in this ratio here, 2R over H, which I've done here is 0.3. And you go to the curve and you look it up, and we see that it's a little bit above 3. So these two curves intersect here. I'll talk about this curve in a minute. Now, as this function goes to 0, we see that the intercept is 3.065. So this would be about a 3.065 stress concentration factor if you're using the stress away from the membrane. Now, this curve, the stress concentration factor, is going to be relative to what we call the membrane stress in the notch. So it would be the tensile stress where this D is shown here. And I've calculated that. So I've calculated what they refer to as the nominal stress here, P over H minus 2R times little h. And I've calculated that for a 1,000 pound load. Excuse my missing units here. You get about 142.85 psi. And if you plug in this 0.3 into this equation, you get 2.125. And from that, we get a peak stress Omax of 303.6 psi, which agrees relatively nicely with our other stress concentration factor. So I suspect that this might be a little low because if we look at the intercept here, looks about 2.1, 2.2. And I have a feeling that there were some terms truncated off from this curve, and they only went to the function as a third highest power, which may be why it's underestimated. I'm not sure. Next, we'll go to modeling the geometry. and applying the loads in ANSYS.